Are you an anthropology enthusiast or a UGC NET aspirant aiming for success? You've landed in the right place. Welcome to AnthroNet Academy. At AnthroNet Academy, we specialize in simplifying anthropology concepts, tackling tricky MCQs, and guiding you through comprehensive preparation strategies for UGC NET and beyond. With engaging content, insightful lessons, and a community of dedicated learners, we're here to make your journey not just easier but exciting. Subscribe now and take the first step toward mastering anthropology and achieving your academic goals. Unit 2. Topic 2.4 Part C Extinct Primate. Contents: Oligocene, Miocene primate fossils. Oligocene epoch. 34 to 23 million years ago. Opidium. Egyptopithecus. Propleopithecus. Miocene epoch. 23 to 5 million years ago. Early Miocene, 23 to 15 million years ago. Stem apes. Proconsul. Afropithecus. Middle Miocene, 15 to 10 million years ago. Divergence of great apes. Keniopithecus. Dreiopithecus. Civipithecus. Late Miocene, 10 to 5 million years ago. Hominin ancestors. Orinopithecus. Oligocene, Miocene fossils. Here's a brief overview of fossil primates from the Oligocene and Miocene epochs, which represent critical stages in primate evolution. Oligocene epoch, 34 to 23 million years ago. The Oligocene marks the emergence of early anthropoids, monkeys and apes, with significant fossil discoveries in the Fayum Depression of Egypt. 1. Opidium. Discoverer, first described by paleontologist Elwyn Simons. Year of discovery, 1965. Location of discovery, fossils were discovered in the Fayum Depression, Egypt. Likely ancestral to both Old World and New World monkeys. Unique characteristics of Opidium. Dental formula, 2:1:3:3, which is primitive and shared with New World monkeys, suggesting a possible ancestral link. Small body size, weighed approximately 1 to 2 kilograms, indicating arboreal habits. Postcranial anatomy, strong hind limbs and flexible limbs adapted for leaping and arboreal locomotion. Cranial features, small brain relative to body size, typical of early primates. Fossil distribution, primarily found in the Fayum Depression of Egypt, dating to the Oligocene epoch, 30 million years ago. Ecological role, likely frugivorous, based on its dental morphology, with potential for insectivory. Phylogenetic position, represents a basal anthropoid, potentially ancestral to both Old World monkeys, catarrhines, and New World monkeys, platyrrhines. Opidium provides key insights into early anthropoid evolution and the diversification of primates during the Oligocene. 2. Egyptopithecus. Discovery of Egyptopithecus. Discovered by Elwyn L. Simons. Year, 1966. The fossils were primarily found in the Fayum Depression of Egypt, a rich site for Oligocene primate fossils. Egyptopithecus is significant as a likely ancestor of both Old World monkeys and apes. Possessed a mix of monkey-like and ape-like traits, including a reduced snout and larger brain case. Likely a common ancestor of Old World monkeys and apes. Unique characteristics of Egyptopithecus. Intermediate traits. Combines monkey-like and ape-like features, representing a transitional form between early primates and later anthropoids. Cranial features. Small brain, approximately 30 cubic centimeters, relative to body size. Forward-facing eyes with a short snout, indicative of enhanced stereoscopic vision. Dentition. Dental formula, 2:1:2:3, characteristic of catarrhines, Old World monkeys and apes. Low crowned molars, suggesting a frugivorous diet. Body size and locomotion. Estimated weight around 6 to 7 kilograms. Arboreal quadruped with strong limbs adapted for climbing. Tail presence. Retained a tail, unlike later apes, which lost this feature. Ecological role. Likely inhabited tropical forests, feeding on fruits and possibly leaves. 3. Propleopithecus. Discovery of Propleopithecus. Discovered by Emile Sennett and others, based on early descriptions. Year, 1908. Location, Fayum Depression, Egypt. Unique characteristics of Propleopithecus. Dentition, dental formula, 2:1:2:3, typical of catarrhines, Old World monkeys and apes. Larger canines, compared to contemporaries, suggesting some level of social dimorphism. Body size, smaller than Egyptopithecus, estimated weight around 5 kilograms. Cranial features, small brain relative to body size, but an improved sense of vision compared to earlier primates. Locomotion, arboreal quadruped with adaptations for climbing and leaping. Diet, likely frugivorous, based on molar morphology suited for processing soft foods like fruits. Evolutionary significance, considered one of the earliest true catarrhines, showing characteristics ancestral to both Old World monkeys and apes. Propleopithecus is a key fossil for understanding the early evolution of catarrhines during the Oligocene epoch. Significance. The Oligocene fossils show the emergence and diversification of early anthropoids and the split between the Old World monkeys and apes. Miocene epoch, 23 to 5 million years ago. The Miocene is known as the Age of Apes, with the evolution and diversification of early apes, hominoids, and Old World monkeys, cercopithecoids. Early Miocene, 23 to 15 million years ago. Stem apes. 1. Proconsul. Discovery of proconsul. Discovered by Mary Leakey and colleagues. Year, 1933. Location, Rusinga Island, Kenya, in the East African Rift Valley. Early ape-like primate from East Africa. Arboreal quadruped with no tail. Likely ancestral to later apes. Unique characteristics of proconsul. Lack of tail. Unlike monkeys, proconsul lacked a tail, a key characteristic shared with modern apes. This places it closer to the ape lineage. Brain size. Proconsul had a relatively larger brain for its body size compared to earlier primates, but still smaller than modern apes. Its brain size is considered a transitional feature in the evolution of primates. Dentition, dental formula, 2:1:2:3, like modern Old World monkeys and apes. Its teeth indicate a frugivorous diet, although it might have also consumed leaves. Body size and limb proportions, estimated to weigh between 10 to 40 kilograms, proconsul had a relatively ape-like body size. It had long arms and short legs, indicating adaptations for life in trees, arboreal lifestyle, though it was not as specialized for brachiation, swinging, as modern apes. Postcranial anatomy. Proconsul exhibited a more generalized limb structure compared to modern apes, suggesting that while it lived in trees, it was capable of moving on the ground as well. Locomotion. Proconsul likely moved as an arboreal quadruped, walking on all fours, but its limb proportions suggest that it might have been capable of some form of climbing and leaping in the trees. Significance of proconsul. Proconsul is considered a key species in the study of ape evolution because it represents an early ancestor of both modern apes and humans. Its mix of primitive and derived traits helps scientists understand the transition from early primates to the more specialized apes that followed in the Miocene epoch. 2. Afropithecus. Discovery of Afropithecus. Discovered by, Afropithecus was first described by Alan Walker. Year, 1986. Location, the fossils of Afropithecus were found in Kenya, primarily at sites like Kaladir and the Nakala region in the northern part of the country. Additional remains have also been found in Saudi Arabia, suggesting a wider range. Afropithecus is an extinct genus of early Miocene apes that lived approximately 18 to 16 million years ago. It is significant in primate evolution, as it represents one of the earliest known apes to display traits linking it to modern great apes, hominoids. Larger-bodied primate with robust jaws and teeth for eating hard foods. Possible precursor to later apes. Unique characteristics of Afropithecus. Dental traits. Large, thickly enameled molars adapted for consuming tough, fibrous vegetation, suggesting a diet of hard fruits and seeds. Cranial features. The skull showed characteristics of a robust face and jaw, resembling early hominoid traits. Locomotion. Likely a tree-dweller with some degree of terrestrial activity, indicating it was an arboreal quadruped. Significance in evolution. It exhibits transitional features between early primates and modern great apes, particularly in dental and cranial morphology. Afropithecus is considered a pivotal genus for understanding the adaptive strategies of early apes and the emergence of great apes in the Miocene epoch. Middle Miocene, 15 to 10 million years ago. Divergence of great apes. 1. Keniapithecus. Discoverer, Keniapithecus was first described by Louis Leakey. Year, 1961. Location, Fort Turnan, Kenya, East Africa. Exhibited terrestrial adaptations and robust teeth. Considered a transitional form between early and later apes. Unique characteristics. Dentition. Thick enamel on molars, suggesting a diet of hard or fibrous foods, like nuts and seeds. Cranial and facial structure. Robust jaw and facial bones, adapted for strong chewing. Postcranial features. Evidence of adaptations for knuckle walking or a similar form of locomotion, indicating a transitional phase between arboreal and terrestrial habits. Evolutionary significance. Often considered one of the earliest members of the hominoid group, Keniapithecus is thought to be a potential ancestor of later great apes and humans. Habitat adaptation. Adapted to both forested and open woodland environments, suggesting ecological flexibility. Keniapithecus plays a critical role in understanding the evolutionary trajectory of great apes and the early stages of hominoid development during the Miocene epoch. 2. Dryopithecus. Discoverer, first described by Edouard Lartet. Year of discovery, 1856. Location of discovery, initially discovered in France, St. Gaudens, Pyrenees. Shared traits with African great apes, like flexible limbs and advanced locomotion. Unique characteristics. Ancestral traits, considered an early member of the ape-human lineage, Hominidae. Physical build, medium-sized primate with adaptations for both arboreal and terrestrial locomotion. Dentition, Y5 molar pattern, similar to modern apes. Diet, likely frugivorous, fruit-based diet, based on dental analysis. Cranial features, small brain case compared to modern apes, indicating early evolutionary stage. Geographical range, fossils found in Europe, Africa, and Asia, showing widespread distribution during the Miocene, approximate 12 to 9 million years ago. 3. Civipithecus. Discoverer, first described by Guy Elcock Pilgrim. Year of discovery, 1910. Location of discovery, fossils were discovered in the Siwalik Hills of the Indian subcontinent, present-day Pakistan and India. Found in Asia, likely ancestral to orangutans. Arboreal, with specialized facial morphology similar to modern orangutans. Unique characteristics. Evolutionary link, believed to be a direct ancestor or closely related to modern orangutans. Skull features, shares similarities with orangutans, such as a concave face, narrow nasal bones, and large canines. Body proportions, smaller body size compared to modern great apes, with adaptations suggesting arboreal lifestyle. Dentition, thick enamel on molars, indicating a diet that included hard or abrasive food like nuts and seeds. Locomotion, mixture of arboreal and terrestrial traits, though primarily adapted to tree dwelling. Geological age, lived during the Miocene epoch, approximately 12.5 to 8 million years ago. Geographical range, fossils found primarily in South Asia. Late Miocene, 10 to 5 million years ago hominin ancestors. 1. Aranopithecus. Discoverer, first described by French paleontologist Louis de Bonis. Year of discovery, 1975. Location of discovery, fossils were first discovered in the Thessaloniki region of Greece and later in Turkey. Large-bodied ape from Europe with features resembling African great apes. Unique characteristics. Facial features, broad, flat face with pronounced brow ridges, resembling some features of early hominins. Dentition, large, thick enameled molars adapted for a diet that included tough vegetation or harder food items. Body build, robust skeletal structure, indicating strong musculature. Sexual dimorphism, pronounced differences in size between males and females. Adaptations, likely both arboreal and terrestrial, with some degree of bipedal capability inferred from skeletal traits. Geological age, lived during the late Miocene epoch, approximately 10 to 7 million years ago. Evolutionary significance, considered a potential ancestor or close relative to the African ape-human lineage due to its cranial and dental similarities to early hominins. Upcoming topic 2.5 Pre-hominid groups. Thank you for watching. We appreciate your time and support. Subscribe to Anthronet Academy for more engaging content on anthropology. Please like, share, and comment on this video to help us grow. Stay connected. We're here to support your UGC NET exam journey to success.